Okay, for our first complex problem number 1, let's go ahead and read the question. So the example is, I walk 5 kilometers east and then 6 kilometers at 30 degrees south of east. What is the displacement? So the first thing I'm going to want to do is draw my two vectors. So first vector is I walk 5 kilometers east, okay? So there's 5 kilometers east. And then I walk 6 kilometers, 30 degrees south of east. So I want to make sure I'm going east. I'm going in the easterly direction, and then I'm going south of it, so south of east. So I'm going off in this direction, and this is going to be my 30-degree angle right here. So I could use a protractor to find that. It's 30 degrees. Here's 0. It's going to aim at this little dot right there, and it's going to be 6 kilometers long. Okay, let's go ahead and put in our angle. So this 30 degrees was right here, 30 degrees. So it's 30 degrees south of east. So we're going south of the easterly direction. Okay, so first thing we want to do is we'll notice that only one of our vectors, this first one, has x and y components. Our second vector it doesn't have x or y components, so we need to make it so it has x and y components. So let's make this vector a triangle. So we're going to, so the 6 kilometers is going to have an x component. Here it is. And it's going to have a y component. There it is. And our overall objective, let's not forget what it is. It's finding the displacement. So sorry, I should have added that in first. So we want to find the displacement. So displacement is start to finish. So we want to draw a straight line from start to finish. And remember, we can always estimate about how far it's going to be if we draw it to scale. It's going to be about 10.2 kilometers. Okay, so we're actually going to find what that value is. Well, if we look at this displacement, we need to know what the length of this is. In order to find that, we need to make a triangle. So I can make a x component of my green triangle. So there's the x component. Here's the y component. Okay? So eventually we need to know what this is, delta D. So that's our question. So let's just go solve this. It's kind of like a puzzle. So we need to solve first. Well, if we find out what y is, then we'll know what this y is, because they are the same length. Okay, we have a rectangle here. So if we find out what x is, we'll know what this length is. X plus 5 is going to equal this length. So let's go ahead and find x and y, and then go from there. So in order to find x, we need to use our SOHCAHTOA. So we'll notice that x is the adjacent side to the angle, so we're going to use cosine. So adjacent over hypotenuse. So cos theta is equal to adjacent over hypotenuse. So this is to solve for x. So cos 30 is equal to x over 6, and we get x is equal to 6 times cos 30, which is 5.2. Okay, we can fill that in right here, 5.2 kilometers. Now let's solve for y. So this is the opposite of the angle, so we're going to use sine theta equals opposite over hypotenuse. We get sine 30 equals y over 6. You get y equals 6 times sine 30. Oops, sorry, 30 equals, go ahead and put that in your calculator. You should get 3.0. So y, I'll do it in another color so we can see, equals 3.0. So that also means that this side is 3.0. Okay? Now we know this x component right here, this whole length, is equal to this length. So we know this one is 5.2 and this one's 5. So 5.2 plus 5 gives us 10.2 kilometers. Now you're thinking, okay, so we have this side and we have this side, but we don't have the displacement still. Well, this is a 90-degree angle right here, so we can use the Pythagorean theorem to solve. So we're going to get a squared plus b squared equals c squared. And just so you guys can see what I'm talking about, let's bring this green triangle out right here. There it is. This is 10.2. This is delta D, or also known as C. That's our hypotenuse. And this one's 3.0. So let's plug in our knowns. So this is A, this is B, and this is C. 3.0 squared plus 10.2 squared equals c squared. So when you solve for c, you should get c equals the square root of 9 plus, let's see, 10.2 squared is 104.04. And you get c is equal to 10.6 kilometers. So that's delta D. So our displacement is delta D equals 10.6 kilometers. But since it's displacement, we know we always have to have a direction. So let's find our direction. Now the question is, what angle are we going to find? So if you look at our displacement is always from start to finish. So this angle right here isn't really going to be helpful in giving us the direction because it doesn't really have anything to do with our little path that we traveled here. So the angle that does have to do it, it's always with our start. This is going to be our angle, theta. And you could use this angle as well. It's just going to be whatever this is plus this equals 90. So let's just solve for theta first and I'll show you. So here's our theta. Okay, so we always want to use what we know. We know 3 and we know 10.2. So our opposite over adjacent. So we're going to go tan theta is equal to opposite, so 10.2 over adjacent. So we get tan theta is equal to 10.2 over 3. And once again, to solve for theta, we need to take inverse tangent. So divide tan on both sides gives you inverse tangent of 10.2 divided by 3. So go ahead and put that in your calculator. Make sure you're doing the inverse function. So second tan, so you should have tan to the -1, and then 10.2 divided by 3. And you should get 73.6 degrees. Once again, make sure that you are in degrees, not radians. 0.6 degrees. Okay, so our displacement is now at 73.6 degrees, and we need the direction. Well, we are going, so we're starting out going south, and then we're moving in the east direction. So we're going east of south. East of south. Okay, let's go ahead and do one more complex problem that's a little bit different. Example 2, 10 meters east, then 8 meters at 40 degrees south of west, find resultant. So often the displacement is also called the resultant vector. Okay, so let's draw it first. So we're going to draw the 10 meters east first. And I'm not going to draw this one to scale. I'm just going to use the ruler to draw a straight edge. So let's say that's 10 meters. And then we're going to have 8 meters, 40 degrees south of west. 40 degrees south of west, so we're going in the west direction and then we're going south, so south of the west direction, so this is going to be our angle, so that's going to be 40 degrees. Always decide your angle first to make sure you're going in the right direction. And remember, I'm just estimating now. So then this one is 8 meters, so it's going to be a little bit shorter than that vector. Remember, the length matters. So this vector is 8, so it's a little bit shorter than the first one. Okay? And let's find our displacement. So our displacement is always a resultant or displacement. Either one is the right term. Start to finish. So our arrow needs to point at where we finish. I'll connect those two. Now looking at this, you might see more than one way to solve the problem, okay? You might see that you can make this 8 meters, you can make it have a y component and an x component on the inside, but I'm going to go ahead and make things a little bit clearer so we don't draw on the inside of our triangle, and I'm going to make the x and y on this side. Since we know this is 40 degrees, we also know that this must be 50 degrees on the inside, because this is a right triangle. So here's my y, here's my x, and we are also going to have an x and y for our displacement. Your goal is always to make triangles and squares. So making squares, or rectangles in this case, makes it easy to be able to solve. So this is our delta D. So the first thing we're going to need to do is find our x and y, because once we know our x and y, we can find these two unknowns. And then from those unknowns, we can find delta D. So x and y. So let's find x first. So if we look at this angle, so 50 degrees is our angle because it's the one that's inside this triangle. Opposite is x. So x is going to be, so opposite over hypotenuse. So sine theta is equal to opposite over hypotenuse. So sine 50 equals x over 8. We solve for x, we get 8 times sine 50. When you plug that in, you should get 6.13. 6.13. Same thing, y. This time it's the adjacent side to the angle, so cosine theta equals adjacent over hypotenuse. Cos 50 equals y over 8. You should get y equals 8 times cos 50 as 5.14. Plug that in, 5.14. Okay, we're almost there. So now we can just transfer our known information over to our other picture over here, our other triangle. So we know that this y is 5.14. Well, both y's are the same, so this is also 5.14. This x is 6.13. Well, the total length of this rectangle right here is 10. So that means this total length is 10. So this little x piece of our red triangle is also 10 minus 6.13. Okay? So from that, we can draw our, let's pull out our little displacement triangle here, so it makes a little more sense. So this is our delta D. So 10 minus 6.13, let's put that in our calculator. You get 3.87. And this side's 5.14. Okay, this is going to be our theta. So let's find delta D using Pythagorean theorem. You get 3.87 squared plus 5.14 squared is equal to delta D squared. So delta D, I'll let you put that in your calculator on your own. Square root of you should get 6.43 meters. Now we need to know the direction at what angle. So we need to find this angle. In order to do that, we're always using the tangent function, okay, always, because we always know the x and y. So that means we always are going to know the opposite and the adjacent. So tan theta is equal to opposite, so 3.87 divided by 5.14. Well, we want that tan over on the other side because we want theta by itself, so we got to take the inverse tangent function, 3.87 divided by 5.14. Make sure you are in degrees. And you should get theta is equal to 37 degrees. And now we have to decide the direction. Well, we're going south and then we're going in the easterly direction. So we're going east of south. Going east of south. There's our answer. There's one more complex problem, number 3. Go ahead and watch that to be able to understand how to do that problem.